Hi everyone. Hi everyone. This is one of the Ethereum builders developer flash talks. So I really like the idea of having this regular talks on this Ethereum builders group, and I'm thinking it would make sense to have some that are also shorter and just kind of cover specific topics of interest. Right now. There aren't too many people involved with the site yet, but that'll probably change as Ethereum starts getting more developer interest. But just to talk a little bit about myself, I'm Conrad Barski. So I've done some books. Here's two of my books. So the two things in the last decade that really got me excited were Lisp programming and cryptocurrency blockchain development. And so, as you can imagine, I've spent a lot of time thinking about how the two concepts can work together. Now, it turns out there's actually a lot of real great benefits if you marry some ideas from Lisp and combine them with Ethereum, because we use lots of JavaScript when we're building Ethereum Dapps, and it turns out there's a really great Lisp compiler that will generate JavaScript, and that is ClojureScript, which is moderately popular development language these days. So let me just kind of talk about some of the properties of ClojureScript, and then we'll talk about why it makes sense to use it when you're doing Dapp development. So first of all, ClojureScript is a Lisp. So what that means in broad terms is that it has kind of a weird-looking programming syntax. So if you look at Lisp code, and I'm kind of assuming here, you may not know anything about Lisp. Probably most of the people listening to this talk already know everything I'm talking about on this slide. But if you do something like call a function, the way you usually do it is you have parentheses like this, and then here we're adding the numbers 1 and 3 with a plus. And so we have a form where we have as the first item in the form the function we want to call, and then the other items in the form are arguments to the function, and then here we see the result. So this is usually what it means to be a Lisp style programming language, and the reason you would want this is because it makes all kinds of meta programming easier, because it has a very easy to parse function calling syntax. Another property of ClojureScript is it's a functional programming language. This means when you write functions in ClojureScript, you usually want to write them so that the result of the function only depends on the arguments that are passed in, and it doesn't interact with the outside world in any kind of way. Now, the nice thing about ClojureScript is it will compile down to standard JavaScript, so you can use it as the front end of an Ethereum Dapp. One particularly interesting thing about ClojureScript is that it's compatible with the Google Clojure compiler, spelled with an S in this case, that has this thing called advanced mode, which is one of the most sophisticated JavaScript optimizers out there. And it does all kinds of very complicated inlining and tree pruning for your program, and generates very efficient JavaScript. So, using ClojureScript can often be just as performant as handwritten JavaScript. And it's actually kind of difficult to use the Google Clojure compiler on regular JavaScript, ironically, because it has all kinds of very strict constraints in terms of what your code is allowed to do. But ClojureScript will handle that for you. Now, why do we care about ClojureScript in Dapps? Well, there's three main benefits that I'm going to talk about in this short talk about how Dapps can benefit from having some of the features of ClojureScript. We're going to talk about immutable data structures. We're going to talk about channels and Go blocks, and we're going to talk about Lisp-style macros. So, what is an immutable data structure? So the basic idea behind immutable data structures, which have been used for a long time in languages like Lisp and Haskell, is that what you want to do is never modify a data structure in your program. So in this slide, you can see I have an old data structure. And so suppose you write a program such that you can take an old data structure, and then if a new item needs to be added to that data structure, you generate a new data structure, which is exactly the same as the old one, except that this new item was added. So you could do this and do it in a way where you don't at all modify the old data structure. You just return a brand new object. Now, in most cases, this would be very inefficient because usually you would have to do a lot of copying of old data and the old data structure into the new data structure. So what immutable data structures give you, and this is all based on an important paper from the late 90s by Phil Bagwell, where he showed that you could create immutable data structures really efficiently if you design the data structures from the beginning in a certain way, and so that it can share structures with the old data structure, but in a way where the old data structure is never modified. And so you can have these situations where you can keep around old versions of your data and have new versions of your data, and you can do that in a way that's efficient and in a way that essentially allows you to make modifications and not have to worry about freeing up old resources. Now, this is very valuable in several ways that matter to Dapps. Now, the first benefit of it is that it gives you better thread safety, because if you have several threads running in a program, it's possible that one thread has an older version of a data structure that you modify in a new thread, and you don't want the old the other thread to get confused when the data structure mutates at an unexpected moment while the program is running. So in this way, several threads can interact with the data structure, and each one of them doesn't have to worry that the data structure will change while they're interacting with it. Now, of course, the obvious question is now, why does this matter if JavaScript doesn't have threading? And we're going to get into that next. Now, the other thing is that one of the very popular libraries right now for doing JavaScript development is called Facebook React.js. And if you're not using React.js for developing your Dapps, I highly recommend you look into that. It's really the way to go. I already know the Augur team is using React.js, so I'm at least on that. I'm not completely on the very edge of development. There's other teams that are doing the exact same thing here. Now, it turns out if you have immutable data structures, React.js can be made a lot faster than it is out of the box. And the key paper for that is, or the key blog post is called "The Future of JavaScript Frameworks" by David Nolan at this link. And at that link, you will see how using immutable data structures allows you to avoid deep compares of JavaScript data and will allow your UI to be a lot faster and smoother. And in fact, Facebook is aware of this as well, as I will talk about in a moment. Now, one of the other benefits of immutable data structures is that it makes it easy to implement time travel. So if you want to have infinite undo in your program, it's much easier to do that in a program with immutable data structures than with regular immutable data structures. And this is very important because an app that's using a blockchain that can have forks may have to actually revert transactions on the client side if a certain fork has a different transaction record than the current fork when it has to switch forks. And I'm going to talk about that more as well. Now, just to point out, there is an alternative available for JavaScript if you want to use immutable data structures. Facebook has this library called Immutable.js, that will give you a lot of these benefits. The problem with that is because JavaScript isn't designed to be immutable, it's very cumbersome to use this, at least compared to using it in ClojureScript, which is designed from the ground up for immutability, and all the built-in data structures already are immutable. So your code can be a lot more concise if you're using ClojureScript. Now, one of the other big benefits of ClojureScript is that it supports Go blocks. Now, if any of you have done Go programming in the Go language, you already know everything I'm about to tell you now. For those of you who don't, this might be a new concept. This is based on a paper, I think, from the 80s called Communicating Sequential Processes. And the idea is that we want to create something that looks kind of like a thread. And in ClojureScript, we start such a thread with the Go command. And what that does is it creates a little, almost like a little coroutine, which is another term you might have heard of when you use this kind of idea in C and C++ programming. But essentially, it's like you can create a thread that waits on input and pushes out output. And what's nice is that all the operations inside of the Go block can be blocking operations. So if we need to talk to the server because we need to either wait for a transaction in the blockchain to be committed, or we need to wait simply for the Ethereum client RPC to give a response, we don't have to use we don't have to block our UI. And however, you can program inside of a Go block as if it was blocking I/O, even though it isn't. So in this example, this is a toy example of how a Go block would work. Here, I'm pushing some output to our out channel. So one thing about Go blocks is that you usually have to communicate with channels, which are just kind of they're kind of like ports that let you send data structures in and out. So we push out the phrase, what is your name? And then in this example, we're assuming the output is being shown to the console. And then we check for the user to put in the input. And if the input is Bob, then we're going to say, hey, that's my name too. And if it's not Bob, then we're going to say that's a strange name. And so if you were to type in this Go block into the ClojureScript console, you would see what is your name. And then we can put into that the in channel the name Lisa, and then it'll say that's a strange name. Now the important thing here is ClojureScript runs on JavaScript. JavaScript does not have any threading support, but ClojureScript does all the proper magic to let you have Go blocks inside of inside of JavaScript. And the reason that's important, in my view, is because we have to keep track of very complicated information about the current state of our transactions on the blockchain, and that's really very different from the kind of UI event handling that our program needs to do. So in the programming that I'm doing right now for my project Groundhog project, is I'm essentially treating the client in the JavaScript client, again, which I'm writing in ClojureScript, as having two main threads in a way. One that handles the user interface, and another one that keeps track of what's happening with the server and handles all server-side events. And here is a flowchart that shows how the Project Groundhog client needs to interact with the blockchain and with the contract on the blockchain. So Project Groundhog is a social network, and in order for somebody to use it, they have to be registered in the social network. And if they're not registered, then we have to first check, have they funded their account with money in the Project Groundhog contract. If not, we ask through the UI for them to fund it, and then we send a funding transaction to the blockchain. Once they are funded, then we have to help them to find a unique name that no one has yet, and then we're going to try to register that. And we keep doing that until we've found a name and we know that it's a unique name. And then once that happens, then they can start using the program. And then we want to wait for actions to come from the client code, the UI code. And again, the idea of this flowchart is this flowchart is managing the interaction between the client and the server. And this interaction is very stateful because a person who's registered needs to be handled very differently from a person who's unregistered when they fire up their client. And so by modeling this flowchart inside of a separate thread, it makes it so that the UI can just focus on displaying things on the UI, and it doesn't have to worry about what state the server is in, because we have a separate thread that's keeping track of what's happening on the server. And again, this is important because we can have forks, and we might roll things back, and we need to be able to handle that. Yeah. So once they're registered, then there's different things they can do. They can post, they can upload, download, or they can view different feeds for different people on the site. And then finally, if they perform an action to exit the Dapp, then we need to do some cleanup. So usually the way you would model this in a JavaScript app is you would build something like a finite state machine. And essentially, this is the same thing when you hear people talking about client-side routing. That's essentially what they're doing. Is they're saying if the program is in this state and this event happens, then we want to go into this state. And you can kind of build a state machine that way by describing routes and how the routes are connected to each other. But with this, what we can do with Go blocks is we can simply take that flowchart that I showed you, and we can actually just copy it line by line to generate a Go block. So here's essentially the Go block right now from Project Groundhog, simplified a little bit so I could fit it on a slide. And essentially all it's doing here is it's pulling in information from the UI and information from the blockchain, and then it's pushing out transactions to the blockchain. And if you were to compare that flowchart I just showed you in this program, you would see that there's a one-to-one match between the different parts. And so this is really nice because we can be right here deep inside of this nested program, and we realize, oh, at this point we need to know how much the user has to tell us how much they want to fund their account with. And we can just block right at this point, and the UI can do whatever it needs to do to get that information from the user. And then once that information is available, then this thread, this very primitive kind of thread, can continue working and handling the next action. And we can handle very complex situations like, if the name has already been registered, then we can keep looping on this while loop as we make the person enter in more and more transactions. So this is really nice because we don't have to write this very complicated description of what our state machine is. We can simply write it in a natural way, as you might do in the old days when you were doing basic programming or something. And the Go block handles all the logic.
Conrad, your mic is muted. If you can unmute.
Oh, how much did I miss? Just a couple of seconds?
Yeah, not much, like 20 seconds or so.
Yeah, I have no idea when that happened.
The previous
That's my computer at that time. Maybe I hit the wrong key or something. Okay, so as I was saying, there's a JavaScript alternative to Go blocks. The new generator functionality in ECMAScript 6 can be used to generate something very similar to Go blocks and channels, and you can use that in Ethereum Dapps because Ethereum Dapps are built on the WebKit stack, and that does support generators. So here's a library that will let you do something like this, but it's not quite as elegant as it is in Clojure. Now, one thing you might think when you look at that flowchart that I showed you is what happens if a person starts the Dapp, they're not funded, okay, they add some money, they fund their account, then the website helps them find a unique name, and then all of a sudden they're registered and they're good to go. And then all of a sudden, at that point, there's a horrible fork that's 10 minutes long. And all of a sudden, we go on a different branch of the fork where the person isn't even registered yet to the website and their account isn't funded. Would that example I showed you, would it be able to handle that type of extreme fork situation? And the answer is no. I have to make the Go block a lot more complicated to handle every single possible forking event that could happen and not have the client get confused. However, it turns out one of the way Clojure works, because it's a Lisp and it supports metaprogramming, the entire Go library in ClojureScript is actually just a regular library written with Clojure Macros. So the guy who wrote the Go library called core.async for ClojureScript just wrote it like a regular computer program, except that computer program actually has the ability to modify the behavior of the ClojureScript compiler, which is a feature that's mostly unique to Lisp type languages. So in the same way, we could modify Go blocks to actually handle reversing events where where something happens and then we find out there's a fork and we need to rewind the program back to its state like a minute ago. The last 4 blocks in the blockchain need to be thrown away and handle that in a consistent way. So I'm actually modifying the current core async library in ClojureScript to create a new type of reversible Go block. And what you can do here is you can see if I run this Go block, it's kind of complicated to understand exactly what's happening here. You can see it prints the first step, then if I put in some data, it'll say second step, and then I put in some more data, it says third step, and then I can call a special command called rewind, and basically what I'm telling it is the last 2 pieces of data I sent you were bad because they were on a fork, a branch of the fork of the blockchain that got forked away. And so we need to pretend that the last two pieces of information that you got no longer exist. And so now if I put in more data, you can see it goes back to the second step. So it went back 2 steps back to step 1, and then after putting in more data, it says second step. So this, I forgot to put in the link, but if you go to Dr. Code on GitHub, you'll see a library called Rewind that's still very, very, very alpha and doesn't have any documentation yet. But I'm going to be releasing that in the next month or so that adds this kind of functionality to Go blocks so that it can handle very complicated forking events. And that's my presentation. Any questions?
This was very interesting. I wasn't aware of Clojure and how you can make these macros. Very interesting stuff. I have to look more into it.
Yeah, well, yeah. The important thing is that the current Ethereum client that is being pushed for production is written in Go. So yeah, you definitely you need to know about Go blocks anyway. And so if you really want to dig into Ethereum at this point, and so if you're going to do that, why not use them in the client as well? So yeah, well, this is a pretty small group. So oh yeah, I see Niran has posted a question. What do you use to use React in ClojureScript? So the library that people are using for that is called OM, O-M, and it actually makes React a lot nicer. So I really recommend looking at that. It's written by David Nolan, and he works very closely with the guys at Facebook. And if you want to see what React is going to look like in a couple of years, OM, it's going to have some of the features of OM. And in fact, since React.js was published, they've already taken on some of the features of OM, like this. So it's kind of hard to know with the immutability library because Facebook had worked on that in secret, whether that came out before or after David Nolan's work in Ohm came out, but clearly there's something. They're looking very closely at what the folks in ClojureScript are using to program in React.
So the other thing is that it seems like you have to kind of re-architect your application to handle the kind of the forks that you're describing that this lets you do. But is it worth architecting your application that way instead of just finding a way to recover somehow? Like, what benefits have you seen from being able to just rewind and go from there rather than fixing things?
Yeah, so I'm not totally sure yet exactly. So there's going to be forking events, and I think what's going to happen in the first few months when the first Dapps come out is the UIs on those Dapps are just going to go crazy when there's some weird fork, and I don't think that we've really developed an industry best practice yet for how to handle forks in a Dapp UI. And so what I'm presenting is sort of the very extreme solution, which is to say we essentially keep a really smart history of the entire program, and when a forking event happens, we can kind of go backwards in time to the point before the fork and recover in a natural way. That might not be the right way to solve forks. It may be the better way to solve forks is to simply say, okay, there's a fork. Let's just assume everything is screwed up and reload the web page from scratch. That may be much smarter. But right now, I'm not aware of how common forks are going to be and how many other weird small hiccups there's going to be and how that's going to cause Dapp UIs to kind of start acting crazy. So I think I don't know quite the answer to that yet. It's possible that what I'm suggesting is way too aggressive of an approach. There might be simpler ways of solving these types of problems.
So I'm really excited about ClojureScript, and I want to use it for things. But what do you think is the best strategy for making sure that you can release an open source project and still get contributions from people when the ClojureScript community and its overlap with the Ethereum community is small today? Like, how do we grow it?
Well, I don't really know. I think what it basically comes down to is that programming a Dapp is very different from programming a standard web application, and there's going to be some friction points with the decision that the Ethereum team made to rely so heavily on WebKit and on JavaScript programming to do Dapps. I think it was a very smart decision, but there's going to be points where programming a Dapp is going to be very different than programming a regular web application. And so the question is, are those differences so small that we can just some JavaScript best practices can kind of sidestep them, or are they going to be so severe that you really kind of need something on the inside the client that is a little smarter and does some meta programming and some fancier programming techniques to kind of hide a lot of the ugliness that's involved. And so if that's true, then ClojureScript might be really interesting for Dapp development, for more than just a tiny niche of whatever, one person or 5 people. But it's hard to say right now. I mean, the bottom line is there's no way I'm going to write my Dapps in JavaScript simply because I do JavaScript for my day job and I don't want to go home and do more JavaScript. So whether people contribute or not, it doesn't matter. I'm going on my own path, and so knowing that already, it's not a problem I really need to deal with because either way, I'm stuck in ClojureScript because this is a fun project for me, and that's what I want to program in.
Cool. Well, thanks for putting this presentation together. It was really interesting.
Yeah, thanks for joining. So thanks everybody for joining our presentation, and we'll see what other people start presenting on the Ethereum Builders group. I think there's a lot of potential there. So, all right, bye everybody.
Goodbye.